The expectation of a random variable is just the centrality of that distribution, meaning that where is the mass concentrated, where is it focused of this random variable. So the expectation is often denoted with an uppercase E. And the idea here is that we're just going to take the expectation of some kind of random object. So I'm just going to denote the random object with uppercase X. And just the thing you need to keep in mind is that everything that's inside the bracket is what we're going to take the expectation on. All right? So if you've used functions in math before, this is nothing different. We just take the expectation on everything that's inside the brackets. So the way we find it then is that we need to find all possible outcomes for this random variable. So we need to sum over all possible outcomes from the first one, which I'm going to denote as state 1. We need to sum over state 2, state 3, state 4, until we get to the final state, which I'm going to denote as uppercase S. We need to find the probability to end up in each state. So that's going to be the probability of our random variable to take one particular value. So notice here, uppercase, random, it can take multiple different values. And a lowercase letter denotes that, okay, this is one specific outcome. So if we are rolling a die, oh, we got 3 dots. That's the outcome. So we want to know the outcome in this particular state. So I'm just going to put a little index here to denote that it's the outcome in state S. So now we know the probability to end up with that particular outcome. Now we just need to multiply that with the value in that outcome. All right? So you can almost view this as a weighted average, where the weight is the probability and the value is the x. One thing to note is that these sums need to sum to 1, okay? Because everything that can happen need to be covered by our distribution function. So that means that if we add up all the probabilities that are possible, they need to be summing to 1. We need to have the whole outcome space covered. Let's assume that we are holding a portfolio in a world where we have 3 possible outcomes. We have state 1, state 2, and state 3. The first outcome gonna happen 25% of the time. And in this case, we're gonna earn 69% of our portfolio. So the return on portfolio A gonna be 69%, 25% of the time. The second outcome, you can view it all like a mediocre, a regular market event. We're gonna gain 3%, and 25% of the time, we're going to end up in some kind of recession or bear market and lose 43%. And now, of course, the question becomes, what is the expected return of this portfolio? What can we expect to gain on average if we hold this portfolio? So we're just going to apply this equation. So we take the expectation of our random variable. In this case, we don't use x because now we want to know what the expected return of our portfolio A is. So we take the expectation of the returns of our portfolio. But exactly as we did with the x, we're going to do the same thing here. We need to sum over all possible outcomes. So we have 3 possible outcomes. In outcome 1, we're going to end up 1/4 of the time. So we have the probability times the value in that outcome. And this is the bull market where we expect to gain 69% if we hold this portfolio. We need to add the second outcome, which is going to happen half the time, times the value in that outcome, which is 3%. And then we need to add the final outcome, where we're going to lose 43%. So once again, note that the probabilities need to sum to 1. So 1/4 plus 1/4 is 1/2. And then we need to add the last half, which means that this sum to 1, we have a correctly specified outcome space. And if we put this into our calculator, the outcome gonna be 0.08. So on average, we expect to gain 8% if we hold this portfolio. All right, now we know how to take the expected returns. In the next lecture, we're going to look at the variance, which is a measure of spread. See you there.